Hello everyone, welcome back to week 6 stream processing. In this video, we are going to take a look into Kafka stream joins. We are going to make or set up an example in which we will have two topics in which the data could be joined on, and we are going to build a topology or basically our Kafka stream application trying to do this. So in this example, what we are going to see is we are again going to use our writes topic. And if we remember from our example previously, the write topic had a key of drop-off location. We are going to basically use this key for our joining. In Kafka, the joins are only possible on the key of that particular message. So for our case, we are gonna modify our producer a bit and use the drop-off key or the drop-off location ID as the key in our writes topic. Then what we are going to do is basically create another topic, which is called a pickup location topic. The pickup location topic is going to have a pickup location inside the message itself. And what we can do further from there is basically use these location IDs to join them. Let's say we are working for a ride-hailing company, and there are taxis which are dropping off people at a particular location ID. And then there are people who are actually taking the taxi from a particular pickup location ID. If we can match these two in some specific amount of time, then we can match the taxis to these people, right? So maybe the driver is coming in and he will come in 2 or 3 minutes into that location ID. And the pickup location ID is already there, and we can just match these two, rider and driver, together. And this is possible using Kafka streams. And basically that's what we are going to now code. So I set up an example for us already. I made some general things like I set up the main class. I have our class ready. This is basically the create topology. And I will show you why we do that in the next video. And then it's just the Kafka streams, if there's an exception, and then we just start the stream. I'm just printing it out in case what's the status of the stream for a certain amount of time. And whenever the status is running, we just exit it, and then we just wait till we basically shut down the stream itself. So this code should look very familiar to you from our count example. We are not doing anything very specific to our stream building or our application, but we are just doing some basic setup or setting up the skeleton for our Kafka stream application. Also, we have all these properties which we have already worked with and have already seen. And we also are taking the input topics. So basically input write topic is coming from writes. I created another topic called writes location. This basically provides us the pickup location ID. And we have also the output topic. In addition, what I did was also create a producer, which I'm going to use as my pickup location producer. This code should look very familiar to our previous example of JSON producer. And in this case, what we are just doing is basically taking one of the examples. So I've created a new class, pickup location. It just has a pickup location and the date time of now. And basically that pickup location is produced to Kafka in this topic called ride_location. So let's go back to our stream and build this example. And in this case, what we need to do now is to basically create a topology. So let's build a topology. Let's go to new. So we need a stream builder to build a topology, and we need the data coming from the input topic. So let's do the Kafka stream. So we know that we would need Kafka stream reading from writes. Let's just import this. So writes, and we have our stream builder dot stream. The topic name is our input write topics, and we also need to set up a consumed. So consumed with surds.string, and now I also created a custom surds. So let's take a look into this class. So the custom surds is nothing but it's just capturing our surds in in a common class. So instead of having the same get, write, search method in each of our classes, I just made a static method and put it in a general class or a helper class if you want. So this is our rides. Let's also read our other topic, which is basically our pickup location. So pickup location, and this is basically pick up. So it's a stream, so I will just say locations. And then it's stream builder dot stream. The input is input write location topic. I again need a consumed. And in this case also we are producing the key is a string, and what we need is basically get pickup location search. So this pickup location search is absolutely same to our gets write search. It just has this different JSON value type. And obviously we can also make this code way much better, but I just want to keep it like this for now. We can actually make it generals, and that will make it easier. All right, so the first thing we need was to select the key. So we need to select the key, and we will have a key comma value. We know our value is basically coming from this PU location ID, and this is what we want. So what I basically did was just change the key for our streaming application. So let's name this as var pickup location keyed on PU ID. All right, something like that. Pickup location key on it. All right, perfect. So this would also be a stream. So if you actually look into the K type, it's basically a K stream again. So we didn't do anything special. We just keyed it differently. And now what I want is basically writes.join, and the join should be on my new keyed PU location ID. So both the keys should match, and both of them should have the same type. The second thing is basically I need a value joiner. So let's just create a value joiner. Let's implement a method, and in this case it would be basically this should be write, and this should be pickup location, and basically write dot. So let's first create some cases, right? So what do I want to return in this case? So I want to return something like a vendor information. So my application, what it does is basically, if it sees that there is a possibility of a join, then it returns some vendor information, and then we can inform the vendor that, hey, you know what, there might be a possible ride for you, so you might want to inform the taxi driver, because that's the information we have. If we are actually Uber or we are actually some other ride-hailing service, we might have the taxi ID there, or the app ID which the driver is using, and then using that app ID, we can just send the notification directly to the driver itself. Currently, we do not have that information, so we are just going to use and create a vendor info object. So what I'm going to do is basically, I will say, I will return a vendor info. So vendor info, this should also come here. We can replace this with lambda just to make it a bit easier to read, and we have write. So the first thing we need is basically a period. So what time elapsed between the calls? I think it's duration dot between write dot. So when was the drop off date time? Maybe this is in the future. This might be in the past. It really depends. And the pickup location dot. What do we have here? The pickup date time. So when was the pickup date time? So if these two things are in a certain threshold, we might be able to do something with it. So now let's say if period absolute 2 minutes is less than or greater than 10, we should basically return an optional of empty. Okay, I think it's better if you make an optional here. Optional. So if you don't know optional, it's basically a wrapper around null, and that's it. So if you do not have anything, I would have returned null here. So instead of returning this, I could have also returned null. But optional provides you this additional benefit that you need to actually check, and there is a less chance of a null pointer exception. And else, if this is in less than 10 minutes, so the two events happen in less than whatever my threshold is, I'm using 10 minutes, I'm going to produce optional of new vendor info. And what does this vendor info take? It takes vendor ID, which comes from my ride. So ride knows which vendor ID it has. What is my pickup location ID? So the pickup location ID comes from PU. What was my pickup time? So that also comes from my pickup date time. And what was my last drop off date time? So that would come from my this drop off date time. So in the future, what this object can actually give is basically it can give the vendor information, it can give the pickup location ID, and based upon the timestamp differences which you are also providing in the object, somebody else can also make a decision that, hey, does it make sense for me to attach this particular taxi to the next ride or not? All right, so what else do we need? I think we also don't need this because I think Java is smart enough to do this. No. Okay, so let's try what else do we need? So windowed information. So let's see, join windows dot. Okay, so of time difference. So if the events are happening in, let's say, time difference of, because I'm using 10 minutes already. So if the events are happening in between difference of, let's say, 30, maybe 30 is too much of minutes, let's say 20 in this case. And I will also add a grace period, duration of minutes, let's say 5. Grace period generally basically means that if the event is delayed for some reason. So I need to put a return here. So return this. This is my joining condition or my join window condition. There's a third parameter which I need is basically stream joined. Yes, stream joined dot. So I need to define what kind of surds are there. So I will use surds dot string because the key is of string type. Then I will use my custom surds, which is basically of rides, and then custom surds, which is basically of the pickup location. So actually for a join, there is an internal topic which is created. And because of that internal topic, we need to define how that topic is serialized and deserialized, right? So we need that kind of an information when we are joining this data. So this is simple. What we are doing here is nothing special. We just take rides and pickup location. We say, okay, what's the period? If the period is greater than 10 minutes, then just return option.empty. If the period is more, then we return the vendor information. The join is happening on events which are 20 minutes to each other, basically in the 20 minutes time windows. And we need some sort of way to tell what kind of serialization and deserialization to use when we are using this internal data or internal topic for our join. So we have our joint topic now, and this joint topic should also be a Kafka stream. What we can do now is basically we can say, okay, joint.filter, and we will like to filter anything which is basically null or empty. So I will say, okay, filter anything which is present. And then we can also map values. So we do not want to pass on the optional. We can actually say value.get. We can, I think, improve this, replace it to lambda. So optional.get. And this would be our output topic. And what we can also do is just say, okay, to output topic, which is output topic. And we obviously need a produced with this. So we will say produced. And this would be our string and our custom cert of vendor information. So vendor get vendor certs basically. So this kind of becomes my topology. And what I need to return in this case is streambuilder.build. So this streambuilder.build actually gives me the topology I need. And this topology is basically then passed to our Kafka Streams application, which then executes and run it. All right, let me just cross-check it one more time. So we select key, and then we do the time trace case periods. Let me change this to, I think I just copy pasted this from something else. So Kafka tutorial, Kafka stream joined, rides pickup, location dot v1. We read from the latest, and because we want to just output all the messages, we are just gonna use a config of 0. Let's try this. Let's run this and see. So as I said, it's rebalancing and it's running, and now it has basically waiting for messages to come in. And that's what exactly we want. So what I'm going to use is basically my old producers of write. I'm just going to run this. So it kind of just produces messages every half a second. And you can already see that the messages are flowing out. What I need to run also is my new one, which I created with some random pickup location ID. I'm using this pickup location ID because I know this exists in my initial few rides. And there we go. And let's see if we can. All right, so the messages is produced. And let's see if we can see some examples in our Confluence. I will go into my cluster. I'll go into my topics. As you can see, there are a lot of messages being made. Can I scroll this here? No. So let me take this as an example. So where's my stream? So in the Kafka stream, let's see if we can find something. So we can already see that there is some stuff made, and if you look closely, it can already say K-stream joined other and all that stuff. And then this is for the join for the pickup, and then actually the join thing. So you can actually see all the internal topics which are being made. But what we are interested is in our output topic. So vendor information, messages. Let's see if we have any messages coming in. Okay, there is nothing in partition 0. There's nothing in partition 1. Okay, maybe we need to produce our message once again. Okay, it's still just running. Do we have this? Let's see. 1212 pickup location. Okay, so pickup location. Yeah, I think 1212 was something random I wrote. Okay, so let me do one thing. Let me pick up 141. Oh no, so it should be the drop-off location actually. So drop-off 1212. Can we see something? No. So let's pick up 186. And I do 186. I rerun this one. And now it's produced. Let's see if, so the drop-off location is 186, the pickup location is 186. There should be ideally a join now somewhere. So let's, oh yes, there are a lot of messages actually. So we can see now that for pickup location 186, and for these pickup times, we have successfully joined 2 streams and basically produced this message. So in this video, we already saw how to join on multiple topics. We kind of covered some of the advanced features. One thing to remember while joining is to have the same partition count for both the topics, basically. So in our case, the rides and rides underscore location topic should both have the same partition value. So if one is partitioned as 2, the other one should also be partitioned as 2. This has to be co-partition if you want to put it like that. The reason being is how Kafka divides the partitions when it scales. So if you have different kind of partitions, let's say one has 3, one has 2, there would be a mismatch and the keys won't match. So for the keys to match, you have to have similar partition. And basically, that is absolutely a requirement in Kafka. And so please make sure that whenever you are joining, you are kind of co-partitioning or having the same number of partitions for the topics you are joining on. In this video and in the previous video, we actually skipped one of the very important parts, and that's testing. We kind of skipped it because it's easier to explain without actually going through how can you test your Kafka application. But now we have this background to understand how can we divide our code in a way to successfully test our application. So in the next video, we are gonna basically look into testing and how can we test the applications of count and the joins we actually made. And we are gonna basically write some tests for that. See you in the next one. Ciao.